Welcome to a special video for Physics 102. In this video, I provide some comments on exam number 1. I would like to begin by saying congratulations. Your hard work has resulted in a performance on the first exam which is, on average, half a letter grade higher when compared to the results of the first exam in 2 previous iterations of this course. I wanted to let you know that your hard work has really paid off, and I want to thank you for all of your work. Now let's move on to the purpose of this video. In addition to assessment, exams also provide a unique learning experience by providing an opportunity for you to see if you are approaching physics as a discipline in the correct way. Think back to the exam. Which of the following statements most closely reflects how you began each exam problem? Really put yourself in the moment of the exam. I'd recommend you write down which approach you followed. It will help focus your mind during the rest of the video. The former is the more common way to approach studying for physics exams, and perhaps seems an easier way to go. However, as was mentioned on slides 15 and 16 of Unit 1, the exam is written to encourage the latter way of thinking. In this video, we will go through each problem to emphasize what fundamental physical principles were involved with each problem, and what activities and homework corresponded to each problem, i.e., where was there an opportunity for practice with this concept. Let's begin by looking at problem 1. The fundamental concept in this problem was how to add vectors graphically. This material was covered in class in slides 100 through 111. Practice on this concept was provided in CPS number 2, where the setup involved understanding vector addition graphically, along with homework 1 problems 2, 3, 4, and 9. Now let's move on to problem number 2, which involved 2 blocks accelerating to the right. The fundamental concept involved in this problem required an understanding of forces and a Newtonian method of thinking. You had to understand Newton's second law, as F equals ma, because the 2 blocks were accelerating in this problem. You also had to understand Newton's third law to see that the force on block 2 from block 1 was the same as the force on block 1 from block 2. Finally, there was a constraint that both blocks must have the same acceleration. Because of the rather involved nature of this problem, those students who approached this problem using a technique similar to the problem-solving framework provided on the CPS worksheets were in general more successful, because they thought about the physics involved as well as all the constraints involved in the problem before beginning to calculate. Practice with this idea, in particular Newton's second law with accelerating objects, was provided in CPS number 3, as well as homework 2 problems 5, 6, 9, 10, and 14. Practice with Newton's third law was provided in Unit 2 slides 40 through 43, CPS problem number 3, and homework 2 problems 3, 5, and 14. Now let's move on to problem number 3. The fundamental concept in this problem involved understanding position and velocity, and in particular graphical representations of these concepts. This idea was introduced in slides 32 through 41 of Unit 1, and practice was provided on slides 44 through 60 of Unit 1, along with homework 1, number 10. Now problem 4. This problem involved converting a word situation into a vector addition or subtraction problem, and then completing the vector addition or subtraction using components. Practice on this idea was provided in CPS number 2, the video on vectors, along with its associated quiz, as well as homework 1 problems number 7 and 8. CPS number 2 and homework 1 number 8 were very similar in their execution to this problem. Note, several people tried to solve this problem using just geometry. Just as many people tried to solve CPS number 2 using just the ideas of geometry, such as the law of cosines. While this is possible, it's much more work, and very few people who attempted it completed it successfully. Whereas those students who approached this problem using the ideas of vectors discussed in this class were in general far more successful. Problem number 5. In this problem, there were a series of multiple choice questions regarding a woman pushing a block across the floor. similar to the voting card problems that we do in class. Only this time, you are also required to justify your answers in 1 or 2 sentences. This problem really required you to have a Newtonian way of thinking, as opposed to an Aristotelian view, and understand that in Newton's second law, forces cause accelerations, and that these accelerations are changes in velocity, as opposed to the idea that velocity itself requires the presence of a force. Thus, also a knowledge of the difference between acceleration and velocity was required to successfully complete this problem. Practice on this idea was provided in many questions in the Unit 2 slides, the kinetic friction video, Homework 1 problems 7, 10, 11, and 14, and Homework 2 problems 5, 6, 11, and 14. Now let's move on to problem number 6. This problem also involved an understanding of Newton's second law, as it particularly applied to the case of zero acceleration. You also had to understand how to treat forces as vectors. Practice with this concept was provided in the 2D problem number 1 on slide 63 of Unit 2, the 2D problem number 2 on slide 64 of Unit 2, slide 86 of Unit 2, Homework 1 number 7, and Homework 2 number 3, 4, 6, 8, 10, 12, and 13. In summary, the problems on the exam involve similar concepts and techniques to those problems in the slides, CPS activities, and homework problems, but the problems themselves were not identical. Due to these differences, people who understood the fundamental concepts and began each problem from these underlying ideas were in general more successful. If you do not see the connections between the exam problems and the in-class CPS activities and homework problems listed, please come and see myself or one of the TAs. This is an important skill to be able to see the underlying themes between different problems. Being able to do this will improve your success in this course. I would like to end with a famous quote from Albert Einstein, which states that insanity is doing the same thing over and over again, expecting different results. If you did not do as well as you would have liked, please come and see me or one of the TAs. We can work with you to change your study approach for next time so that you will be more successful.